All attendees are in listen-only mode.
Hi, good evening, everybody. Welcome to the April 13th edition of the vBrownbag US. Today's topic is going to be CCNA-DC Section 10, Data Center Virtualization. Tonight's presenter is going to be Joel Sprague out with General Dynamics, and his Twitter handle is @JWSConsult. A couple of housekeeping items. Getting on the conversation. If you hashtag vBrownbag, I will be watching the Twitter handles and keeping an eye on everything and responding to questions both there and within the Q&A session for all of the attendees. Again, our guest is Joel Sprague. Joel, is it Sprague or Sprague?
It's Sprague.
Sprague, I apologize. Joel Sprague at JWS Consult, and his website is joelsccie.com. I'm Chris Williams at mistwire.com. And Joel, if you would take it away, sir, I have made you presenter.
Okay.
Oh, there you go.
Let me make sure I grab the right screen. And get this going here. Well, as Chris said, we are talking about the CCNA data center here. Specifically, we are taking Section 4 of Test 640-916. Those of you who were here last week, I did storage networking last week. This week we're doing data center virtualization, which I'm going to try and keep it short. A lot of this stuff, this is vBrownbag, we're VMware admins. We don't need to be told a whole lot about server virtualization or virtualization in general. So I think this should be a pretty easy run through here. But as before, there's going to be sections where read the book. There's tables and tables of server models, fabric interconnect models, all those wonderful numbers that the test writers love to test you on. So, okay, this is the agenda. We're sticking almost exactly to Section 4 of the test, so that'll be device virtualization, server virtualization, and Nexus 1000V, or network virtualization. We're going to try and fit a live demo in at the end. MyVMware.com refused to let me get my license keys today because it's under never-ending maintenance, so I was not able to get my vCenter up and running again, so we'll probably do a UCS demo instead. Because just like your distributed virtual switch, Nexus 1000V is not much use unless your vCenter is up and running, at least not if you want to change anything. So again, here's the cert guide. It's on its third printing. Buy it if you're taking this test. This is the best single place to go. Amazon, Safari, wherever. You know how to get books. This is the breakdown on the test. This is straight from the blueprint. We are going to the red section here. I've got to remember to switch to my laser pointers first. So we are doing data center virtualization, which does include some unified computing. I'm not quite sure. They split it up, but then talk about server virtualization anyway. I expect there's going to be some overlap with Shane's talking about networking here with the VDCs, and then with the next presenter's unified computing. We'll try and see if we can get you some new things that weren't covered before or next week, but if not, it's just going to be extra review. Again, as I said last week, the best way to study, you can memorize all these charts and stuff, but you're not really going to be able to understand them or even memorize them as well unless you get some hands-on experience with the equipment. The Cisco PEC Labs, dCloud, Lab Gear, they're all free. They're mostly limited to partners, though Cisco dCloud does have a bunch of labs that are open to anyone, not just people who work for Cisco partners. Your best bet is go to the various sites, try them out, see what you can get into. For UCS, there is the UCS Platform Emulator too, which is great. You download it as an OVA. It lets you practice most everything with UCS Manager, and that's actually what we'll probably use for the live demo here in a little bit. So virtualization basics. As Cody loves, how many turtles can you fit on a rock? Or how many virtual machines can you fit on one 2-core server? Virtualization has a lot of different meanings depending on whose books you read, what websites you go to, but basically virtualization is kind of just a general idea is letting us abstract out hardware in a virtual way to get better use out of it. Obviously, there is a lot of advantages to virtualization, though there's plenty of companies that still to this day will not certify their applications to run on virtual hardware, and they make all our lives miserable. But as you see, with virtualization, as we know, we get cost savings. You can buy less physical servers and run more virtual machines on them, which gives you a better utilization of your assets. You get greater stability and higher availability. You can, rather than being limited to one host, if one host dies, your virtual machines are up and running on the next one, either after a restart or immediately with VMware fault tolerance. Yeah, not a lot to that. We all know what virtualization is. Device virtualization. This Shane already went over a good bit. Device virtualization in the case of this test is talking primarily about virtual device contexts on the Nexus 7000 switches. These switches, just like every other piece of hardware out there these days, while they use switch-on chips for the actual network ports, the processors are still just Intel Xeons, and like everyone else, Cisco is realizing they had a whole lot of extra CPU cycles that weren't doing anything with. So with the Nexus 7000, they came up with the idea of VDCs, which lets you essentially run anywhere from 2 to 9, depending on how you want to count it, virtual switch instances on one set of supervisors. So you have your kernel and infrastructure underneath, which are, the cards, the soups, everything. These are all the same and shared across all your VDCs. Same with the manager layer. So your VDC manager, resource manager, interface manager. But then within your VDCs, you have your own set of VLANs, your own set of VRFs, your own routing processes, IP stack, all of that. So, if you have, it's great, say, if you buy a company, you're already running 10.20/16 in your data center. They happen to be co-located in the same data center, and we're also running the same IP space, but you don't want their servers on your network until you make sure they're up to your security standards, which can be a 5, 6, 7-year process. You put up another VDC on the same Nexus 7000. You can connect all their devices, but still have everything off on its own without any communication other than what you control until you make sure that all the security footprint, all the security stance is up to match up to what you're doing. Or just money savings. Say, horizontal consolidation. Say you had test and dev, and you didn't want to buy a full set of extra switches for each of them, but you still want your redundancy. So you have, let's see, I had to look at this one twice before. You have VDC1 and VDC2 on each of your 7000s. So VDC1 is your prod traffic, and it goes up to the core. You have your redundant core, your redundant aggregation layer, redundant access. You have your test dev, another VDC, same box, no additional hardware costs, but separate traffic that you can have your test dev separate from your production. Or same type of idea, but vertical consolidation with VDCs. You have your core and aggregation, and you collapse them down, but rather than doing a full collapsed core, you still have a VDC for core, a VDC for aggregation. So you have your high-speed switching routing here, you have your aggregation where you may stick your firewalls, your IDSs, stuff like that, your regular aggregation layer protocols, and insert them here into the aggregation VDC and still let your core VDC just be your high-speed, fast packet switching and routing keeping everything flowing well. Okay, so we are getting through this nice and quick. We're going to do the first practice question here, which is choose the different types of VDCs that can be created on the Nexus 7000. And no, I did not go over these, as Shane already did, but I'll give you a minute to look at them. That's, I'm sure you guys know already. The answers are A, B, and C. The default and admin, which are two names essentially for the same thing. It used to be with the original soups and old code, you had the default VDC that you couldn't change and then had VDCs past that. With the newer code, they switched it to allow an admin VDC, which is only for administration of other VDCs. It cannot have any physical ports in it other than management, and it's just for managing licenses, so you are not wasting one of your licensed VDCs on management of the rest of the switch. Even companies as big as Cisco occasionally listen to their customers. And then your storage VDC is dedicated to FCOE only. D, OTV VDC, you'll see often a VDC in a diagram labeled as OTV. It's not technically a type of VDC. What you're seeing there, though, is that OTV cannot coexist in a VDC with SVIs, so you will generally have OTV on a stick where it is on a VDC with some layer 2 and layer 3 interfaces, and so that then you can still have your SVIs on your core VDC, OTV, route out to OTV on a stick, and run the traffic over your data center interconnect to the other data center.
Quick question.
Yeah.
Graham is asking, can VDCs be on can VDCs be on different code?
No. If we go back to this diagram here, the kernel and kickstart are the same for all the VDCs on the box.
Yep,
so it's, yeah, and that also, that's, if you're playing around with lots of VDCs, make sure you have, well, make sure you have dual soups anyway, but especially because when you go to update your code, you are going to bounce all those VDCs for the upgrade if you don't have dual soups. Server virtualization. This one was a little tough deciding quite what to go over. Server virtualization on this test is going to cover, the guide has a short chapter on virtualization as we all think of it, VMware, Hyper-V, Xen Server, that type of thing, and then a whole lot on UCS. But they also have UCS in the next section by itself too. So I tried to do a little bit of both. I didn't want to go too heavily into VMware because I think we all know it pretty well here. But again, there's only so much you can fit into an hour or less than an hour if I decide to be chipper and quick. So hopefully you guys will still learn a few things. I'm also partial. I got started on the data center track and have followed it all the way through to the CCIE specifically because of the inclusion of UCS. We've been using them at my job for almost 6 years now, and they're the best blade servers I've ever used. I'm biased, but I love them a whole lot and try and convince people to buy them whenever it makes sense. So I like to talk about them too. So here we have, let's see, I believe it was 2001. VMware really started the modern virtualization movement as we know it. Obviously, you know, your old green screen mainframe days, you were all doing time sharing, you were getting access to the same hardware. It was virtualization in a way. We've had VRAM since, virtual memory since I believe 76, but virtualization as we know it today largely refers to hypervisors, generally bare metal hypervisors such as ESX, and you can argue whether or not Hyper-V is a bare metal hypervisor. I won't touch that one. But this is the virtualization we're used to today. We all know it. We love most of it, hate some of it, but keeps us all employed and lets us run a whole lot more virtual machines on a lot less hardware. I know my primary data center I work on, we have gone from 74 racks of physical servers and storage down to, I think I'm down to 39, and even of that, maybe 12 of them are actually full. Between virtualization and the UCS blades, it's a whole lot smaller footprint. There's still just as much management or more, as the number of Windows installs hasn't gone down, but the footprint and the amount of potential hardware failure points has all gone down. It's all allowed us to be sleeker, run more efficiently, run more cost effectively, and just basically let us improve our business model. And I know a lot of you guys see the same thing every day. This just shot of your VM settings. You've known this, seen this. Obviously, this is just a vSphere 6. This is actually from my UCS platform emulator VM. Virtual Machine 7, I know that's what the OVA is. I'm not going to upgrade it. This will apply a little bit here, what we'll see to what UCS is doing, though. So this is standard hypervisor software-based virtualization, where you are presenting a fully virtual hardware instance, with the exception, of course, before someone says it, of a paravirtual or a VMXNet with pass-through, but a fully virtual hardware instance to a VM. I'll come back to the management one. I got my slides out of order. UCS is doing a very similar thing with hardware, but it's actually with a hardware server. So what Cisco UCS is letting you do is take your server virtualization and abstracting everything on this list into something called a service profile. At its core, this is just an XML file, not that dissimilar to a VMX, that is hosted on the Fabric Interconnects and applied on top of a physical server blade. So whereas here we see the NICs, as we know, it has their max, the amount, well, this doesn't really change, but we can go in, we can set the BIOS settings, stuff like that. With UCS, we have not just the NIC max, but the amount of NICs, the WWNs on the HVAs, the BIOS settings, BIOS firmware. So say if you need different firmware versions for different operating systems, stuff like that. Even the number of NICs. UCS uses VICs, or virtual interface cards, that use VNTag, which Shane talked about with FEX, I believe, to basically create virtual NIC instances and virtual HVA instances on that VIC card that communicate back over the unified fabric to the Fabric Interconnects. You can have as many NICs as you want. Standard install for, say, a ESX host might have 2 data NICs, Fabric A, Fabric B, 1 vMotion NIC with failover, and then 2 management NICs, A and B. So fitting kind of the platform we're used to, but instead of adding physical NICs into a card, these are all just abstracted from the virtual interface card in the UCS server. Now, UCS does all that by having the UCS manager on the Fabric Interconnects. So your old standard blade model, every blade chassis, you have LAN connections, you have SAN connections, you have management. So, your C2000 might have 4 SAN connections, 2 to each fabric for every chassis, 4 LAN connections, 2 to each core switch, 2 out-of-band management connections, and then multiply that by however many chassis you have. So like my primary setup right now, I believe, has 6 5108 chassis. With UCS, all these LAN, SAN, and management connections just come into a pair of Fabric Interconnects, and that can then manage anywhere from, I believe it's 20 to 40 chassis hooked up on the back end, depending on the model of fabric interconnect, the expansion modules you have, and how many links you run to each chassis. That single point of management then means network trunks all my VLANs to just these 4 or 8 uplinks, and I can then tag those VLANs to any server I need to under there. The SAN fabric all comes in just over those 4 uplinks, and I can then map those the vSANs to whichever servers I need there. Not only that, but since, as it says here, we abstract out the WWPNs, you can then set up, say, my normal config, like I said, we have 5 chassis, so at most 40 servers, you figure 80 WWPNs. These WWPNs, which I'll show you later, can be pulled from a pool of WWPNs. So when you first deploy your UCS, you can set up create 80 WWPNs in that pool, give the whole list to your storage guy, and say, create me a zone for each one of these mapped to our 4 main net apps, set them all up, create the zone, script it out, and then anytime I create a new ESX host that then pulls those WWPNs, it's already mapped to the 4 net apps, and then you just have to give the storage guy say these 2 particular port names are on that server, map the correct storage for an ESX55 host, and that's that. The zoning's already been done. You already knew what the WWPNs are. You didn't have to wait for that blade to show up from Cisco, get plugged in, and look at what the port names were going to be. Same thing with MAC addresses. If you were doing, say, zone-based security on something where you only wanted certain MAC addresses to access a restricted host or something else on your network, you already know what pool of addresses that MAC address was going to come from. You could have that already configured. Not only that, you could already have created the service profile with all these settings that was going to go on that blade when it showed up, and even if told them before it got there, told them specifically, we're going to have a new host next week, it's going to have these MAC addresses, these WWPNs, make sure everything's set up and ready for it. So as soon as it shows up, we can just put it in, power it on, it's already pointed to the gold image on that LUN, it's ready to go. So UCS, by abstracting all this out, gives us a lot of the speed and flexibility that we're used to with VMware. These days, if I get a new VM request with virtualization, I can, I think we have it scripted out that even with all the security apps and stuff, it's about a 20-minute install, and most of that's just getting everything put into RSA, the various scanners, stuff like that. UCS lets us have the same kind of speed with physical installs, which is great if you're in a high turnover environment, or alternatively in a high security environment where you want to know all those settings, everything else, before it even shows up on the network. So, as you can see, I'm a convert. So here we're going to look at the UCS computer hardware naming. This is worth learning. You're going to see here there's a lot of models. They're on Gen 4 now for servers, Gen 3 for fabric interconnects. There's a lot of blade models. It's a lot of things to memorize. But if you remember the naming convention, it makes it a little bit easier. There is some logic to the naming. B-series servers are blade. C are chassis or rack mount. There's also E servers, which I've never seen. Those were actually a blade that go in certain ISR routers. If you have a really small branch office, you want just an ISR router, a single site server with some storage, maybe a read-only domain controller. That's what it's for, something like that. And the M are the new modular servers, which are not in the certification guide, but I think are coming on the next version of the CCNA-DC. Those are where they split up the compute and the storage even more than they already are. Then you get the model number. The first number, simple, it's a number of sockets. So a B200 is a 2-socket, B420 is a 4-socket server. Simple. Something else to remember is that for the blade servers, anything with a 2 is most likely going to be a half-width slot. There's been at least 2 exceptions, but they're both deprecated now, the B230 and the B250. Anything starting with 4, up to this point at least, is always going to be a full-width slot. So that, again, it's little things like that will help make it a little easier. You can narrow it down. You know, if it says you get a question along the lines of you have a single chassis, you want to fill it up with 8 servers, which blades can you use for this? I don't remember if that's a real question. It's been 2 years, but something like that. You know you're not going to be able to put 8 blades in a chassis if they're the 4-socket blades, because those are always going to be a full width, which means there's only going to be room for 4 of them in a chassis. And then the second part is just the scalability and capabilities. This floats a little bit. They try and meet this, but they don't always. The B200s, for instance, and the B22, well, you figure 200 has 0, 0 here. The B22 has a 2. 2 is bigger than 0, but the B200 is actually a more powerful blade. It holds more RAM. The B22 is kind of the bottom end if you need stuff for, you know, if you have a requirement to have a physical domain controller or a small IVR that doesn't have a whole lot of disk usage or CPU usage, but needs to be its own physical box. That's where you're going to use something like the B22. The B22 ended again with the M3. There is no M4 version of that, which is the latest. The fabric interconnects, we are, as I said, on the 3rd generation here. I couldn't find a single graphic that had both, so these are a little ugly. The main difference you're going to see, the 1st generation were the XP. So you had 10 gigabit Ethernet or fiber channel, not both. The fiber channel started on the right-hand side, generally with the fiber channel was in a 6-port expansion module, I want to say, 6 or 8, with 10 gig E on the left-hand side. The 2nd generation switched to unified fabric ports, so it still started with Ethernet on the left, fiber channel on the right, but the ports could do either. Basically, if you know your Nexus switches, the 6100s were the equivalent of a 5010 or a 5020, just with the UCS manager chip on them too. The 2nd generations are the 5500s, so these are a 5548 and a 5596, again with the UCS manager chip on it. And now we have the 3rd generations, which I'm very excited about. They don't have the best backwards compatibility, but what they do have are 40G fixed ports and the accompanying new 40G I/O modules, which is what connects the fabric interconnect to the chassis. Not only does that, of course, let you get faster speeds, but for those of us who are looking for more capabilities, but also always cost conscious, you know, ideally your business unit is a profit center, you want to maximize your profits, you run 2, these are licensed by port. So if you run 2 40 gig ports to each chassis, you get twice as much bandwidth as 4 10 gigs and only use half of the ports on your license count. Boss is happy, his boss is happy, your profit margins go up. You can ask for a raise the next year. So these are nice. Whoop, did I miss something?
Is it that easy? Wow. I hope everybody's taking notes.
Yeah. Well, It's that among many other things. Let's say I managed to do that
okay.
this year, but it was documenting $1 million a year in savings, plus the CCIE, plus some high-profile outages that I was the one who managed to fix. But
There you go. Okay. Truth comes
the
out.
ports savings are part of it.
Okay, gotcha.
Every little bit helps. And anytime you do something like that, as a side note, make sure you write it down, especially document anything you do when you're putting out a fire that your boss's boss or someone higher sees and comments on.
Yep.
When you're asking for a raise, your boss needs to justify at least one level up. So if they've already heard your name, saw you fix something, copy emails on that, notes, whatever. Keep that next year when review comes around. It'll make your day.
Well,
It won't
career
help
advice
you
and
pass that stuff.
CCNA troubleshooting. This is a fantastic webinar.
I try. Okay, now we are at the virtual interface cards, which I mentioned in passing earlier. Hey, when you've been in the business 16, 15, 18 years, something, you have to try and help other people too.
Totally. I'm going to mute myself now to stop interrupting. All right.
So we are looking at the virtual interface cards. These are the network cards that are in the blades that you see in your UCS chassis. What are great about these, the first gen cards in the UCS were what you would think of as your adapter cards, and basically an FCOE adapter in one of your regular rack mount server. 2 ports, they're FCOE. They had, so basically you had equivalent of 2 network ports, 2 storage ports. Nothing fancy, nothing all that interesting. Now with the VIC cards, they started giving you the capabilities of actually, this 2x10 is not right, so ignore that. Oh wait, no, that's right. These are actually the C series cards. The B series ones are the 1240 and 1280, but they're the same idea. What you're looking at mainly is these 2 lines here. These are dynamic and the total number of virtual interfaces. These cards use the same VN tag technology that Cisco uses in their FEXes that lets you take anywhere from 1 to 8 ports on your 5000 or 7000 series and basically expand it out to the anywhere from 24 to 48 ports in a FEX module, and it takes that same technology and puts it into your servers. So where you have your 2x10 gig connections to your Fabric Interconnects or to your 5000s, you can actually abstract that out to up to 256 VNICs or VHBAs, which gives you, you can have dedicated NICs for iSCSI, for voice, for data, for whatever you need. Now, obviously, the traffic is still going over these 2x10 gig links, but because they are separate NICs, you can set different port profiles on them. You can set different QoS. You can set different management information. And if nothing else, as I said before, it makes life easier for these server guys. You get people who we're all used to, say, 5 NICs for a VMware host. Redundant management, redundant data, vMotion. You can give a VMware admin he has no knowledge of what servers B series or C series you have underlying. He just knows, I want these 5 NICs. You can give him that. You can give him 2 separate NICs for iSCSI. And you're not having to install more NICs in your server, more interfaces. All you're doing is configuring 2 more virtual NICs on that blade or on that server. I really meant to grab the B series chart for this, but it's the same type of thing you're going to be looking for, 1240, 1280. Like we saw with the B series, it's the same kind of thing on the C series server here. UCS started out I think when we first bought ours, there was maybe 3 models of each with the M1s, but Cisco's done really good about getting a lot of different models to hit any needs. And I expect, though I continue to avoid the announcements because there's just never enough time in the day, that HyperFlex will be shipping on UCS servers, probably something like the 240s or the 260s. And Cisco's just going to keep expanding these lines out to try and meet any need, whether it's lots of CPUs, slots for GPUs, small footprints, lots of storage, whatever you need, there's probably a UCS server that's going to do it for you. Here's the same type of thing except with the B series here. These right here, the B200 M3s and M4s, are the sweet spot that most people are hitting for VMware hosts. I actually have purchase orders in for another 20 of these, I think, across a few clusters. You're looking at 8 of these servers in each of your chassis, 3/4 of a terabyte, up to 36 cores last I checked, and they may have the 20-core CPUs in there now. You can have up to 80 gigs of NIC, and I think with the 3rd generation that might be up to actually 160 gigs now. I'd have to look again at the 1340, which is the new VIC card. They have, as you would expect, they have RAID SD cards if you want to boot the hypervisor off SD card. If not, you have iSCSI boot, you have FC boot, you have FCOE boot. You have plenty of bandwidth for fiber channel and FCOE iSCSI for your regular data disks. These are just workhorse little blades. I love them. We've been using the B200s all the way back to the M1s, and they've worked great, though my 10-node M1 cluster is now, I think, a 4-node B200 M3 cluster and has lower utilization on those 4 hosts than I did on the 10 before. So Cisco, as you see, keeps coming out. They have the Haswells. They have, they stay up to date. They work with Intel and make sure that anything new that comes out, you're going to see them soon in the, the next generation of servers. Okay, so we are doing a question about a UCS here. It looks like we are going to get through this presentation pretty quick here today. Unless we still have the live demo, but which of the following is true? Cisco UCS is the newest unified communication system architecture by Cisco. Cisco UCS is a blade server. Cisco UCS is a unified computing system composed of hardware and software. Or Cisco UCS is a rack mount server. This one, hopefully you caught during the little lectures here, but it is, of course, B, C, and D. I can guarantee you if you put UCS on your resume or on your LinkedIn, you will, though, get plenty of calls from recruiters who think UCS is Cisco's new unified communication system, and you will have to continually tell them you do not work with VoIP. Or you can learn VoIP, and when they give you a call, you can land a new job. Yes, more career advice.
Why not both? Hooray!
Actually, I think Cisco actually does ship stacks similar to the FlexPod and vBlock from someone that are pre-installed with a call manager. But I'm not a VoIP fan, so I avoid it. Okay, describe the Nexus 1000V. Again, this is something that there's not a whole lot to it that we don't already know using VMware. I hope there's not many people using standard vSwitches. I know standalone servers, obviously, or if you have a small node, it can be easier to do a standard vSwitch. I have it on my test lab here at home, but generally anytime you are doing more than 3 or more hosts, going with the distributed virtual switch so you have the single point of management, it's kind of a no-brainer. Nexus 1000V is the exact same idea, uses the same APIs, but instead of just being managed through vSphere, it is running NXOS and is generally managed through SSH, like a standard Nexus switch. So the Nexus 1000V, the best way to think of it is it's a modular switch, like your Nexus 7000, except it's all virtual. So your Nexus 7000, you think the SOUP 1, SOUP 2, these are actually going to be VSMs on your VMware hosts. Each of these, well, ideally, since they're each a separate OVA, you'll have them on separate VMware hosts in your cluster. And then each of your line cards are the virtual Ethernet modules, which is actually just a VIB that installs and runs on each of your hosts. One of the nice things about the Nexus 1000V is really the manageability. Especially with larger businesses, you are going to quickly see that systems, storage, and network are probably all going to be separate teams. And as much as I love the fact that UCS lets us manage all that ourselves, just get a trunk from the network switches, the networking team doesn't seem to like that. They like having their control over everything. So things like UCS and Vmware, where everything's done on our distributed virtual switch, they get a little itchy, and it can make people fight back and forth if you're trying to troubleshoot an issue, you're going to get the pushback. That's not our device. You have to figure it out yourself. Emailing packet captures back and forth, it just gets hairy. So one great thing about the Nexus 1000V is that it lets you go back to your regular management by the network team. You can tell them, we've installed, we want to install this new switch with your help. It gives us all the advantages of the distributed virtual switch we had in vSphere, but it runs on XOS. So you can manage it the same way you manage all our core switches. It plugs into all your regular NetFlow and management tools. And now when we have trouble, you can do your part with the troubleshooting and have visibility down to the VMware level, which is something that the network team has been missing since things have moved from physical to virtual. Other than that, the Nexus 1000V, when it came out, was worlds ahead of the distributed switch in vSphere. These days, with 5.5 and especially with 6, the Nexus 1000V has a much smaller use case. Just VMware has, when VMware made the VDS, they brought in 200, they borrowed 200 engineers from Cisco, had them, I think, for 18 months, and really did a very good job. They started out, it was a little rough, but as they kept updating it with each new version of the hypervisor, it's gotten really good. And most times you aren't going to find a whole lot of need for the Nexus 1000V these days, but if you're in a large siloed environment, it's great for management-wise and for politics. Technology-wise, there's not much you can do these days with Nexus 1000V that you couldn't just do with the vSphere distributed switch. And actually, if your network team is really picky, these VSMs do not have to run in your virtual environment. They can actually buy the Nexus 1010 or 1020V, which is just a one-rack use C server that runs the virtual machines for these supervisor modules. So you can tell your network team that everything is theirs, you're not touching any of their equipment, and you can avoid all those fights there. Okay, so now we're going to have what I believe is our last practice question here, and we are going to ask, what are two main advantages of a VMware virtual distributed switch when compared with a VMware vSwitch? I know I didn't really go over this, but I'm hoping you guys already know, so I'll give you a second to look at the answers here. The answers, of course, are 2 and 3. 1 and 4, they don't even make sense as possible answers. I'm not sure quite what they were trying to say there, but I think those are actually supposed to be answers to UCS Manager because those are names of tabs in the UCS Manager. Not a great practice question, but it's from the certification guide, so in theory it's practice towards what you'll see on the test. Live demo. Okay, so as I said, my vCenter server has decided that it is no longer licensed and I can't get in my not for resale licenses. So let's see if I can bring up UCS Manager over here. Oh, and I have no service profiles right now, so we can see exactly what this is. As I said, the equipment, LAN, SAN, and admin pane, so I think that's what that question was trying to say there. UCS Manager runs on the chips of the Fabric Interconnects, and what it does is it just really gives you a single point of management for all the servers in your cluster. As I said, you can have up to 40 chassis off a single cluster. So 40 chassis with up to 8 slots means you can manage up to 320 servers here from this single point. You have KVM access, power, you can control their network and storage connectivity, manage firmware, all that just from a single point. So that in itself will save you countless hours through the year as you're just trying to manage your servers. This is the emulator. I could hop on a real one, but I didn't have a chance to go through and make sure I had any that were scrubbed to make sure I wasn't giving away clients' information, so I figured we would stick with this. So the main thing you're going to see here is I wanted to show you guys what all you could choose with a service profile. So the service profile is basically you're configuring everything we saw on this slide right here. You're taking all this information for a server and abstracting it out into an XML file in the Fabric Interconnects, and it just then applies all these settings that you chose to a physical server blade and powers it up with these settings. So when you go through here, you're going to say, normally you're going to build a template with all the settings and then create a profile from that. If I do that, though, we're just going to be using all pools and you won't see everything. So I'm going to actually create a service profile in expert mode here and walk through it quick, and we can get out of here on time. So first of all, you're naming the service profile. It's like naming a VM. Name it something that makes sense. You can see already here from the beginning, you get to choose your UUID. You can either type it in manually if you wanted to type in something strange, and it will check that UUID against the rest of the pool or the rest of the cluster, or you can choose one of the pools which you have already created or you can create a new pool. These pools, it's exactly what you think it is. If it's derived, that's going to pull the UUID off of the server blade itself. You generally only do that. Or no, this is the prefix, so sorry, ignore that. Some things with the old virtual interface cards, you can actually pull like the MAC address from the card, the one that's burned in, instead of using one from a pool. You don't generally do that. The assignment order, you generally want to do sequential. Default picks them with some logic that's written into the code, but no one knows what it is. Sequential picks them like you would think, so 001, 002, 003. UUIDs, you go from 1 to 27. It's pools, you're going to see this with a lot of things. MAC addresses, port names, everything. It's 1 through, you have 27 UUIDs there. It's dead simple. But this is just showing that for building a server, you can define just about everything. Why I named a UUID pool iSCSI, I don't know. And then here, again, if you go into expert mode, you can create as many NICs as you want. You can have it on Fabric A or Fabric B, which are the two separate fabric interconnects, with or without failover. All the modern cards will automatically failover from A to B if the fabric interconnect goes down, or even if just the uplinks go down. You can choose which VLANs are trunked to that NIC, which one is the default. You can set the MTU. You can choose the MAC addresses, again, from a pool, or manually choose one. Pin groups, which I don't have any created, actually let you pin that NIC to a particular uplink to the network. You can tweak the adapter policy for different operating systems. You can set QoS policies. Basically, you have all the control you could think of if you had control of everything from your server up to the network, and all the settings in the BIOS on that NIC or in the drivers on that NIC. All of that is still accessible to you here in the service profile, and you can create this all ahead of time so it's waiting and ready to apply directly to a blade. And you, of course, are not limited to just the one NIC. You can create however many you want, up to the 256 mentioned before, depending on which VIC you have. You get the same thing here. You get to choose, you can create HBAs. One thing here, there is actually 3 types of pools for storage. There is WWNN, which is your node name that we've covered before. The WWPN, which is the port name, or you can create a WWXN pool, which you can use for both. The advantage to the WWXN is you can set this to derived, and then if you select WWXN, it will choose the port name and node name from the WWXN pool. And then again here with the storage, you get the same type of control you had with the VNIC. So you select the fabric, you can select the vSAN. I have one vSAN on each fabric here. It'll automatically update the dropdown. As you see, Fabric B has vSAN 200, Fabric A has vSAN 100. Again, there's pin groups. You can control which uplinks the traffic goes out. The max data field size, you can change that in theory. You're going to have a pretty obscure storage setup if you need to change that. Again, you can set your adapter policy for VMware. You can set QoS policies. This applies more specifically if you're using FCOE traffic rather than just straight fiber channel, where you would want to set the QoS policy possibly to QoS policy that put the traffic as COS3 for FCOE. Oh, the local storage policy too, you have control over RAID modes. Obviously with most of the B series you are limited to 0, 1, or no RAID. This is particularly useful if you want to control which types of blades are associated to. Say you had a bunch of B200s, some that had 2 internal disks because you were booting, say, domain controllers off local disk, but you wanted your ESX host to only boot from SAN. You could choose no local storage and make sure this would ensure that it does not choose a blade that had hard disks in it. It's not a big concern, but if program A bought the servers with the hard disks in for their domain controller, program B bought the servers with no hard drives in for their ESX hosts, it just keeps you from having to move the service profile to a different blade later or have someone complain that they're paying for a blade being used by someone else. Yes, the live demo is working so far. Zoning, most of the time you are not going to do zoning in UCS. The exception is going to be with the smaller direct connect setups. Especially if you're using, say, the UCS Mini, you might have a NetApp FlexPod setup with the switchless cluster where the controllers are each hooked directly to the fabric interconnects. Then you would do zoning on the fabric interconnects because you don't have a fiber channel switch to do it on. Most of the time, if you're ponying up for UCS, for B-Series, everything else, you probably have separate fiber channel switches you're going to do the zoning on, but it's there if you need it. Cisco kind of saw from the start, I think, that there's going to be use cases where you are going to have the storage hooked up directly, either FC, FCOE, or even iSCSI, so things like zoning on the fabric interconnects made sense, and because they're based off the Nexus 5000 series, which has zoning in the NXOS anyway, it was simple enough to just add that GUI onto the top in UCS Manager and make it accessible. This is another one you tend not to do a whole lot with, but just in case there's a need, you can actually choose what order the vNICs and VHBAs are placed. So say, well, actually I've done it sometimes on VMware hosts in particular, to make sure that the vNIC with your management networks is placed first, so that ESX then sees it as vNIC 0 and you don't have to choose a different NIC for your management network. It defaults to the one you wanted. Most of the time, other than that, you let the system perform the placement. It will actually distribute the vNICs and VHBAs across any modules that you have. Say you have the something like a B420 that has 2 slots and you have 2 VIC 1240s in there, it will spread your vNICs and VHBAs across those VICs. Boot policies. Again, this is your boot order in your BIOS, except a little more, just there's more you can define. So not only can you do local disk, CD-ROM floppy, I must be running 2.1 because I don't have the virtual CD as an option. So this is an older version of UCS. This is what the CCIE was testing on, though, and still is for the next 2 months, which is why I was running it. But you can also add SAN boot. One thing you'll see here, I did not create an HBA, but if I was doing SAN boot, you would have, and you would want the VHBA names to match from here to the VHBAs you created, so it knows which HBA to bind to. You create your SAN boot and add a SAN target. Let's see. So say this is NetApp 1, head 1. If you save this as a boot policy, then that boot policy is going to be accessible for any service profile you create. So now I created that once. I can have all 300 servers automatically booting off of head 1, LUN 0 on NetApp 1. All you have to do now is on your NetApp, you create your I group for each server, map LUN 0 to it, and all your servers are automatically booting off the NetApps off their own LUNs, and you've set it up once rather than going in every single rack, 300 rack servers every time they come in, configuring the boot config, pointing it to the WWPN on that NetApp, configuring it to boot off LUN ID 0. That's the kind of stuff where UCS just saves you a huge amount of time for management. Even with that 4-node B200 cluster I was talking about that I built, we saved a ton of time being able to use these policies that could be reused. When you extrapolate that across 200, 300 servers, it's huge. And that applies for all these policies here. So say maintenance policy. This is one you're always going to want to do. For some reason, the default maintenance policy on the B200 is the reboot policy is immediate. So if you make a change that requires a reboot, click apply, and that policy applies to all your servers. Every one of those servers is going to reboot right then. So you never want that. You're always going to want to change this to user act so that you make the change, it'll pop up down here. There's 20 servers that need a reboot, acknowledge, and you can acknowledge them one at a time and reboot them after putting them in maintenance mode. That's still, I think in 2.3 even, the default is still immediate boot, and I don't know why. So we've created our service profile. We've set the NICs, the MAC addresses, the storage adapters, what to boot from, everything. Now we get to assign it to a server. So here you can select an existing server. I have 8 servers here. I must have some full width servers because you see that this slot show no memory, no chassis there, or those are the C series and I'm just not wide enough. Yeah, those are the rack servers. Okay. So you can choose an existing server or you can assign the server to a pool. What you'll see with a pool is you can create servers, you can either manually add them or you can create a pool qualification. So as I was saying with the local storage, you can create a pool qualification where the pool will automatically populate with, say, every server with 256 gigs or more. Safe assumption those are probably going to be ESX hosts or big database servers, so you put them all in a pool. Or you say every server with virtual interface cards. You might only use the cheap non-virtual interface cards for standalone servers. Anything with a virtual interface card shouldn't be used for that. So stuff like that. Then all you do is choose blade pool, and it will choose whatever the next blade is available in that pool, or even if there's no blades available, when you put in a new blade and acknowledge it and it's UCS sees that the blade matches those qualifications, the service profile will then apply to that blade and boot up later when you put it in, which is great for, say you have your blades in a colo, you don't have anyone of your own on site, you just pay for hands and eyes. You don't have to worry about them doing anything in particular. They put the blade in, UCS sees it, starts to power it up with that service profile you created when the order first came in for that new server, and it's ready to go. 15, 20 minutes later, it depends on how long. If the blade's been sitting on the shelf a long time, it probably has a different firmware than you're looking at, so it's going to take a couple reboots to apply the firmwares, apply your service profiles. What you'll see, which I can't demonstrate, is this is just the emulator, but when you apply the service profile, it actually boots through a couple times with a little Linux image that is on the Fabric Interconnects and applies all those settings. So it configures the VIX, it applies the MAC addresses, WWPNs, installs the firmwares that you've chosen with your host firmware package, all of that, and then gets the server ready and boots it up with the settings you've chosen. And then that is, well, again, even more policies. There's anything you could think of is controllable here. Most of these aren't too big. The one that you may use, particularly in a high security environment or a colo with a lot of turnover, is a scrub policy, which is you can set a policy that when the profile is removed from a blade, if there are internal disks, it will scrub the disks and it will scrub all the BIOS settings just to make sure that any settings, any data, anything that was on that blade is removed once that client is no longer using that blade. And that's about it. If this was real life, we would now Yes, it's going to cause a configuration failover because I don't actually have any hardware and I did not configure that Mac pool properly. So I think that's about it then. So let me make sure I didn't miss anything here. I got Cody's Turtles, hardware, Fabric Interconnects, Fix, Nexus. I meant to do the demo on the Nexus 1000V, and I apologize for that. But it is what it is. VMware and their maintenance schedules on their sites are always fun. I think that's it. Did I miss any other questions here?
Let me double check everything. Local, no, we're good. Mr. Sanchez is happy to be getting career advice. No, I think we're good. Cool.
Cool.
That was awesome. Thank you, Joel.
Sure.
For both the review and the career advice. Time to go brush up my resume. Ooh, cool. Okay, so we're good for that. Was there any last minute things that you wanted to say, Joel?
I don't think so. Just like it says here, you can contact me, Joel, JWS Consult. You can tweet me if there's anything I missed. Let me know. If the gentleman who asked about hard versus soft zoning last week is here, I have not forgotten. I have about one paragraph left, and I will post that hopefully tomorrow on joelccie.com. But
cool. Do you remember that person's name?
I missed that question for you. I did not see the name.
Okay, all right. Cool. Oh, and Graham says now I need to go learn voice. It was Graham that was asking about the hard versus soft zoning.
Okay.
Graham Mitchell.
Yeah, Graham, I have it typed up. It should be on Joel's CCIE tomorrow. I try and write it and then let it sit for a day, and then I generally go back and find I've been rambling and cut it down some and clean it up before I post it.
Cool. Let me hit the stop recording button real quick so that